In this example, we need to find the phasor based on cosine transformation of each trigonometric form. Then we are going to find the magnitude and our angle. So before we start this problem, it's important to note that the magnitude is going to be our V max for this equation, and that our angle is going to be this angle right here. So for this problem, we don't have anything that we need to add or change because it's in this form. So if we get rid of these black spaces, we're going to see that our magnitude is this 170 and our angle is our negative 40 degrees. And this lines up perfectly with our given equation. Now we're going to do the same thing for part B. Our magnitude should be this 10 because it is our V max. So this is 10 here. Now our angle is not 20 degrees. When we solve this, it has to be just like in part A, always in cosine. So not sine, but cosine. So to convert sine to cosine, what we're going to need to do is subtract our angle for the sine by 90 degrees. So we will have a negative 90 degrees plus our 20 degrees. That means we're going to have a negative 70 degrees. And this is because if we graph our cosine and sine, our sine wave is going to look something like this, and our cosine is going to look something like this. We can see that our cosine starts right here, and that's the max point, and our sine starts right here, and that's the max point. These are both, even though it doesn't look like it on the drawing, these are just both supposed to be at 1, so they're both on the same kind of y line. However, x distance apart is 90 degrees. The cosine, we can say, lags behind our sine by 90 degrees, which is why we need to have our negative 90 degrees in here. So that is the answer for the second part. Now for part C and D, it's a little bit different. We are going to have to add these together. To add these, we have to convert them to what I think is called the rectangular form. So to do this, we are dealing with I. So we're going to first start with our I1. This is going to be our I1, and this next part is our I2. So in our I1, we have our V max, which we know to be 5, and then we have our angle, which is 36.87 degrees. We need to check to make sure these are both in cosine, which it is, so we can continue writing our I2. And our I2 is 10 angle negative 53.13 degrees. And now we can write them in the form where we have V max out front, and then we have cosine times our angle plus j times the sine of our angle. And then we're going to do this for our I2 as well. Once we do this, we are going to factor in our V max into both of these and find our sines and cosines, and then we are just going to add them together. We're going to get these values, so then we're going to have a 10 plus j times a negative 5. Now that we have this, we can convert this back into our phasor equation and get our magnitude and our angle. To find our magnitude, we are going to use a Vm is equal to the square root, and then we want our real number, which is the 10 squared, plus our imaginary number, which is our negative 5 squared, and this is going to give us approximately 11.2. So this is going to be our V of m. Now we want to find our theta, and we know that our theta is equal to tangent of negative 1, and then we're going to have our imaginary number over our real number, and this is going to give us approximately negative 26.6 degrees, and this is equal to our theta. Now we need to check if our angle and our equation right here are in the same quadrant. So if we graph this, we can see that our real number is going to be our x, and then our imaginary number is in our y-axis, and it's a negative, so it'll be down here. So it's going to be somewhere in this quadrant. Our angle is also somewhere in this quadrant because it's negative, so this checks out. That means our Vmax should be 11.2, which it is, and our theta should be, or our angle should be negative 26.6, which it also is. Now we're going to solve for part D. In part D, we have our voltage 1, which is going to be this part right here. We are going to write this as our V1 with a 300 because it's our Vmax, and then our angle of 45 degrees inside of it. For our V2, it's going to be a little bit different. Our Vmax is negative 100. We can see that because it is out front in our equation. However, this is a sine, not a cosine. And we know to convert something from sine to cosine, all we need to do is add negative 90 degrees to it. So if we add negative 90 degrees to our 30 degrees in the sine, you're going to get an angle of negative 60 degrees. Now we can write out the form in the same way that we did out here. And I'm going to do it once, where we have our Vmax, which is the 300 magnitude, and then inside of here we have the cosine of our angle plus the j times the sine of our angle, which is 45 degrees for this example. And j just represents an imaginary number. That's what that means. Now we're going to do the same thing for our V2. From this, we are going to get this equation right here. If we are to graph this early, we are going to have our x in this direction, and our imaginary number, which is in our y-axis, in this direction. So we need to look for an angle that's in this first quadrant. Now we need to solve for our Vm. Our Vm, as we know, is equal to the square root of our real number, so 162 squared, plus the square root of our imaginary number, which is 299 squared. And this will give us our Vmax, or the magnitude, is approximately 340 volts. Now we need to solve for our theta. And then we know that our theta is equal to the tangent of -1, and then inside of here we are going to have our imaginary number over our real number. And after we do this, we're going to get that our theta is approximately 62 degrees. Now our theta is a positive, and so it has to be in our first quadrant, which checks out right here. Again, that means that our theta has to be 62 degrees, which it is right here, and our Vmax has to be 340 volts, which it is right here. And that is how you would go about solving this problem. If you want more introduction to circuit analysis or phasors, there's a playlist with over 100 problems and notes for this entire coursework below the like button in the description below.